All right, Programming 12, let's build this cool sketch. I'm calling this the Mover Network because it's got these cool kind of nets of things going around. So just to make sure everyone's clear, the circle thing that's moving around is the class we're going to build. It's very similar to your movers you made at the beginning of this unit. And the thing that's different about them, I think, obviously, is that they're aware of each other. Yeah, aware is a fancy word. But they are looking at the other movers. Each mover looks at the other movers, and based on some math about the distance, like decides to draw a line to the nearby movers, and the distance kind of controls the thickness of the line, right? The closer the mover is, the thicker the line is. So we're going to use the distance function quite a bit in this, and I think it'll be great. Okay, so I've already written the sketch. I'll show you what it's like, and I recommend you take in this sketch. Like, you can type it up. I think that'll be great, but definitely kind of go over it. There's going to be some tricky stuff in here for sure. So follow along with me, my students, as we engage into the realm. Okay, I'll stop. Okay, let's go. Here we go. So here's our main tab, and I hope you notice it looks quite similar to the movers. So maybe going to be a couple of differences, right? But a lot of it's quite similar to your earlier movers. This main tab hasn't changed a lot, has it? Let's see. Yeah, we got, first of all, we have our array. It's an array of mover objects, and we have a mover class over here. We'll come back to that in a minute. And this is our number of movers. You know, you could change this number and make fewer or smaller, and the whole thing should change as I change this number. So that's kind of cool. We have to instantiate our array. And that means basically the array doesn't exist. It's at this point here, it's a null pointer. And what we can do is we can construct it using the new keyword, because an array is also an object, and somewhere in Java there's an array class. And we tell it how many movers we want to store in this array at this point, so that we plug in the number of movers. Then I have a loop that's going to go from 0, because arrays are indexed from 0, all the way to number of movers, well, one less than that actually. So go, in this case, we'd go up to 49. And at each point, we would say, movers sub 0, make a new mover, and then go on to the next one, and then movers sub 1, make a new mover. So we're basically kind of filling our array with our movers, and we'll see, this is our mover constructor here, right? Here's us calling the mover constructor. So we'll see what that actually does in a minute. Okay, and over here, wow, that scrolled fast. I forgot that I'm using my fancy mouse here. So here we got our another loop, and the loops, kind of structurally speaking, are quite similar to each other. If I just get them on the screen at the same time, basically the guts of the loop, the int I, the while I, and movers, the I++, like that's exactly the same here as well. It's just, what are we doing? So in the draw function, we're not building the movers, they were built already. Now what we're doing is we're telling them to act, and I've broken the show into two different parts. We have the show body, which is like the circle, and then we have the connections, which is like the network. That way I can just kind of like comment out, like, I don't necessarily always want to run. I think it looks pretty this way. Yeah, like I think it looks quite nice. So so I can just kind of comment that out as I desire. But this structure, does it look familiar to you? Like, does it look like kind of like the movers we did before? Hopefully this structure is making sense, and you have a good feel for it. Okay, so now let's go. Oops, sorry, hit my microphone. Let's go over to the class itself, the mover class. So we'll switch over to the main tab here. So here is our, here's our mover. It has as instance variables. Remember, instance variables are all the things that, every mover gets. And they're called instance variables because each object that is a mover is called an instance of the mover class. So all your instances are getting an X, a Y, a VX, a VY, and a D. So in other words, a location, a velocity, and a size, like a diameter, because it's a circle. I just mostly randomize these things. I set all of my movers to have the same diameter, but the X's are randomized anywhere on the screen, and the velocities are randomized. Any, between some whatever numbers those are. You can choose whatever numbers you want, really. You could have them whipping around real fast if you want. But that's my story right now. So the act function is pretty straightforward. They're just going to be moving and bouncing off the walls, right? So I've made two functions. I have a move and bounce off edge, because it's good to break down your functions into sub-functions. It's self-documenting. It's reusable for future if you wanted to like make something similar, but you want to take kind of modules from a mover and build it in something else. So it's always good to break down your functions. So here's my move function, classic, just like changing the x by vx and changing y by vy. Very classic stuff we've been doing for a long time. And then the bounce off edge, also, very basic. We've been doing this for a long time. If we hit the side of the screen, then reverse the vx. We hit the top of the bottom of the screen, then we reverse VY. So this is classic stuff. We also have the show body. Wow, it's a circle. It's got some transparency in it. I don't know, just making it a little mysterious, a little, I don't know. I'm not sure what, it just kind of looked cool. But it's just a circle, so who cares? The connections, however, the connections are pretty interesting. Let's just pause for a minute. Can I run this again? Let's just pause for a minute to look at the connections. So again, we're having a circle that is looking at the other circles, a mover that's looking at the other movers. And for each one, it is going to choose whether it draws a line or not based on the distance. So what we're going to do is have each mover loop through the array of movers, measure the distance, and decide to draw a line and decide how thick the line should be. So within our show connections, we are going to have a loop. That loop is going to look, not too much different. I'm back on the main tab here. Here's my draw function. Like this loop here is kind of going to be a similar kind of loop as to what we actually want to build inside of this function. So effectively, it's a nested loop. Like we're looping on the outside to call all the movers show connections. But inside the show connections, it will also loop through the array. So let's go look at that. Here it is. Hey, look, this starts off exactly the same, right? We're going to be going through all the movers. We're going to start at 0. And here's where it gets a little more interesting. So this is us. I don't know if you guys can see this too well. I think you probably can see it pretty well. I don't know, whatever. We'll move it up on the screen. We'll have like the whole thing in focus so I can explain it one piece at a time. I will mention that we got our while, our I equals 0 and our I plus plus. It's all the same guts of the loop. The gears of the loop are the exact same. So what I do is I measure the distance. X and Y, by the way, are going to refer to this mover, whichever mover I'm calling the show connections function from, right? So it's like the current mover. And it's X and Y. So it's going to measure the distance between this X and Y and whatever mover we're currently on with I, because I is going to go through all the movers, right? It's going to be, maybe this particular one is the one we're looking at. So it's going to like, in one frame, it's going to go through all the movers and, one at a time measure its distance, right? So the first time through, it's going to be, mover 0, and then it'll be mover 1, mover 2, and so on. So what we do is we just take turns measuring the distance between this mover and another mover. So if that distance, and I stored it in a variable, we could have embedded this all in one line, but I don't know. I like to keep things neat and readable. So if you like deep, long lines of code, then you could merge these together, but I like keeping it separate. Well, basically I say, hey, if that distance is less than 200, now this isn't required or anything. I just thought it was cool to like make them go away after a certain distance. So they only kind of like link together when they're close, or relatively close. So that's cool. So if it's less than 200, actually do some stuff. If it's not less than, or I guess, or equal to 200, then we don't do anything. We just move on to the next one. So, that's good. But what do we do if it's close to us? Well, first of all, I'm going to do a little map function. So you might have to like refresh your memory about the map function, because this was one of those challenging things. We used it for sliders. Do you remember that? Programming 11? The joy of sliders. Oh man, it was so fun. But the idea was that, we're going to be, converting from the distance. In this case, it's a transparency value. Like they're gonna like fade to transparent the further away they are. So the transparency, it's gonna range from 255 to 0. And the distance is going to range from 0 to 200. So when they're like right next to each other, then we have maximum transparency. And when they're on the edge of disappearing, like the edge of being too far apart, then the transparency is 0. And then anywhere in between this distance, it'll choose an appropriately, proportional value in this range for our transparency. Now, A only becomes a transparency value because we plug it into the stroke function. So that's important. And yes, again, you could technically squish these lines of code together if you're fond of very long lines of code, which, most people are not, especially if you are the one reading it as opposed to the one writing it. But anyways, I digress. So then we just like, whatever, this is just, make things pretty. And then we draw a line. We draw a line from one mover to this mover to the one that we're deciding on. And that's basically the story. Just to be clear, if we didn't care about this like vanishing thing, we could just connect all the lines. But all this kind of if statements and this math is just for making those things fade away. And that's what we're doing there. Okay, so there you go. So that's basically our project and how these things are functioning with each other. I hope you enjoyed looking at it and making it. And now the whole purpose of this wasn't really for this project, although it's cool to know how to make it. The new thing that we're gonna go now to focus on is changing it to use p-vectors and array lists instead of just like xy, vx, vy, and arrays. So stay tuned to the next video where we'll jump into the meat and potatoes. What is that? Well, I'm not sure. I'm just going to stop this video before I embarrass myself some more. Thanks, everybody.